Points A and B are 70 kilometers apart on a highway. A car starts from A and another car starts from B simultaneously. If they travel in the same direction, they meet in 7 hours. But if they travel towards each other, they meet in 1 hour. Find the speed of the two cars. So in this sum, first we have place A and there's another place B which are 70 kilometers apart. So we mark that. This is place A and here is place B, and the distance between them is 70 kilometers. So this is 70 kilometers. Now from this we have two cars. Here we have car A and car B, and they travel in the same direction. And when they travel in the same direction, they meet in 7 hours. So now here the case 1 is when they're traveling in the same direction. We'll write down the speed, the time, and the distance. We'll take the speed of car A as x kilometer per hour and car B as y kilometer per hour. Now when they're traveling in the same direction, it is given here they take 7 hours. Here it takes 7 hours when they're traveling in the same direction, which means the time here is 7 and the B also travels for 7. Now we know distance is speed into time, so the distance traveled by A will be speed into time, and the 7 into x, which is 7x. And the distance traveled by B is speed into time, that is 7 into y, and that is 7y. Let's mark this on our figure. So we have A starting from this point, the first car, and it moves down. The distance traveled by 8 we know is 7x. And when we have B starting from here and also moving along, and it meets at point C. This is where both the cars meet. And the distance traveled by B we see is 7y. So again, so A travels in this direction, and the B also travels in the same direction, and they both meet at this point C. Now if you look very carefully, we see that AC is equal to AB plus BC. Now AC is the distance traveled by car A, this is AC, and the distance traveled by car B we see is BC. So let's put our values. So we have AC is 7x, now AB is 70, and BC is 7y. This is our first equation. That's 7x equal to 70 plus 7y, which means 7x minus 7y equal to 70. And if I take 7 common, I get x minus y equal to 10. So x minus y equal to 10 is equation 1. Just to go over it again, so we had AB plus BC equals to entire AC. In the second part of the sum, if they travel towards each other, they meet in 1 hour. So here again A and B, and we know the distance between A and B is 70 kilometers, and the cars are traveling towards each other, which means here this is traveling towards, and B is traveling here towards each other, and they meet after 1 hour. So we write down car A, we have car B. We know the speed of the car. We have taken the speed as x, and the speed is y. In this case, the time now, they meet after 1 hour. So this is 1 hour, and here is 1 hour. We know the distance is speed into time, that is x into 1, that is 1x. And here the distance is 1y. So 1x, they meet at this point C. This is point C. So if we see the distance traveled by car A is AC, and the distance traveled by car B is BC. So this is the distance traveled by A, that is AC, and here is the distance traveled by B. So we'll mark this as 1x, and here is 1y. And if you look up in the figure, we see that 1x, or we'll see that AC plus BC equal to AB, which means we have 1x plus here 1y equal to AB, and AB we know is 70. So x plus y equal to 70 is equation number 2. So our first equation was x minus y equal to 10, and now we have x plus y equal to 70. If we add up both these equations, we have 2x equal to 80, so x equal to 40 kilometer per hour. So the speed of car A, or car starting from point A, is 40 kilometer per hour. However, you have to write here speed as kilometer per hour, here kilometer per hour. A sailor goes 8 kilometers downstream in 40 minutes. So let's take up downstream. Now for downstream, we know the distance is 8 kilometers. He's going 8 kilometers downstream, so distance is 8 kilometers. Now the speed for downstream will always be boat plus water, which is x is boat and water is y. So this will be the speed downstream. And the time they have given is 40 minutes. Now 40 minutes we've got to convert into hours. So that will be 40 into 60, which now works as 2/3. We know distance equal to speed into time, which means distance, which is now 8 here, equal to speed. And we saw the speed we have taken here as x plus y downstream, and the time is 2/3. We take 3 on the other side, so we have 8 equal to 3/2 equal to x plus y. And when we cancel, we get 12 equal to x plus y. This is equation 1. Now for case 2, he now returns in 1 hour. So returning means he goes upstream. So if he returns, he is covering the same distance, which is 8 kilometers. He is coming back to the initial position, so 8 kilometers up. Now the speed, since it is upstream, it's against the water, it is boat minus water. As we have taken boat as x and water as y, so the speed upstream will be x minus y. And the time, here it's given, he takes 1 hour. So time is 1 hour. Again, we have distance equal to speed into time. Now this is for upstream, and here the distance is 8, speed is x minus y, and the time is 1. So we have 8 equal to x minus y. This is equation 2. If you recollect, we had equation 1, which was x plus y equal to 12. That was equation 1. And now we have equation 2, x minus y equal to 8. Now we will add both these equations. We add 1 and 2. And then when we add 1 and 2, this cancels out. So you have 2x equal to 20. And x is 20 by 2, that is 10 kilometer per hour. And if you recollect, we have taken x as speed of the boat. So speed of boat equal to 10 kilometer per hour. Now to find the speed of the water, we substitute x equal to 10 in any one equation. Say x plus y equal to 12. So 10 plus y equal to 12. So y equal to 2 kilometer per hour. So in such sums, you must remember that for downstream, it is x plus y, the speed. And for upstream, the speed is x minus y. That is, boat plus water is downstream, boat minus water is upstream. Before we get on to the next sum, we must know what you mean by downstream. When a boat is going downstream, means it's going along with the water. So if the water is and the boat are in the same direction. So this is water and this is the boat. So the speed downstream, the speed of the boat is taken as x and that of the water is taken as y. So the speed downstream will always be x plus y, means boat plus water. But if the boat is going upstream, upstream means against water. So of course the water is always going downwards. It's flowing down and we take water as y kilometer per hour, but it's going upstream, means it's going against the flow of water in this direction. So this is the boat and that is x. So the speed upstream will always be boat against water, which is x minus y. So speed upstream is x minus y, speed downstream is x plus y. A boat goes 30 kilometer upstream and 44 kilometer downstream in 10 hours. In 13 hours, it can go 40 kilometer upstream and 55 kilometer downstream. Determine the speed of the stream and that of the boat in still water. Now as we read the sum, we'll fill in this table. So a boat goes 30 kilometer upstream. So distance upstream is 30 kilometer and 44 kilometer downstream. So 44 kilometer is the distance downstream. Now we know the speed upstream is x minus y, that is boat minus water, and downstream is x plus y. Time is distance over speed. So the first time here comes distance over this speed. So that is 30 over x minus y. This is time upstream. And for time downstream is distance over time, which is 44 over x plus y. Now the total time taken, they said, is 10 hours. So we have time upstream plus time downstream equal to 10 hours. So 30 over x minus y, that is time upstream, plus 44 over x plus y, that is time downstream, equal to 10 hours. So here's the equation. Now we need to solve this. So to solve this, we'll say let x minus y be equal to a, 1 over x minus y, not x minus y. 1 over x minus y equal to a, and 1 over x plus y equal to b. So this is 30. We separate the coefficient from the variables. Here 44, 1 over x plus y equal to 10. So this is 30. We're going to substitute here as a, and this is 44. We substitute this as b equal to 10. This is equation 1. Now let's take up case 2. Here it takes 13 hours if it goes 40 kilometers upstream. So 40 kilometer upstream. Upstream is x minus y, and 55 kilometers downstream. 55 is the distance. The speed for downstream is x plus y. Now the time for upstream will be 40 over x minus y, that is distance over speed, and this will be 55 over x plus y, distance over speed. And the total time they said is 13 hours. So time upstream plus time downstream equal to 13. This is time upstream, this is time downstream. So we have 40 over x minus y plus 55 over x plus y equal to 13. So this is our equation. Once again, we'll say let 1 over x minus y equal to a, that's what we have taken, and 1 over x plus y equal to b. So our equation 40, we separate the coefficient and the variable. So this is 55, 1 over x plus y equal to 13. So this is 40, here 1 over x minus y, and this would be a, plus 55, and 1 over x plus y here would be b, and this is equal to 13. This is equation 2. If you recollect, the earlier equation was 30a plus 44b equal to 10, and now we have the equation 40a plus 55b equal to 13. This was equation 2, and here was equation 1. Now we need to equate the coefficient. This is 30 and here is 40. So if we take the LCM of 30 and 40 is 120. So we need to make this 120. So we'll multiply this by 4. We need to make this 120, and we multiply this by 3. So on multiplying the first equation multiplied by 4, we get 120a plus 176b equal to 40. And the second equation we multiply by 3, and we get 120a plus 165b equal to 39. So here are our equations. This was equation 1, equation 2. We equated the coefficient. Now we change the sign. Cancel this. Here when you subtract, you will get 11 equal to 11b equal to 1. So b equal to 1 by 11. Now to find a, we substitute b equal to 1 by 11, say in equation 1. And our equation 1 was 30a plus 44b equal to 10 in this equation. It wasn't, we didn't name it as equation 1, but we'll substitute it in this equation. So we have 30a plus 44. Now for b, I'll put 1 by 11 equal to 10. So we have 30a plus 4, this cancels out, equal to 10. 30a equal to 10 minus 4, that is 6. So we have 30a equal to 6, a equal to 6 over 30, and we have a equal to 1 by 5. Now for the next part, we know our b is 1 by 11 and our a is 1 by 5. So a was 1 by 5 and b was 1 by 11. If you look back, what was our a? A we had taken as 1 over x minus y, which is equal to 1 by 5, and the b we had taken as x 1 over x plus y, so it is 1 by 11. We resubstitute. So x minus y equal to 5 and x plus y equal to 11. So this is equation 3 and equation 4. So we have put them together, x plus y equal to 11, x minus y equal to 5, plus and minus cancels, 2x equal to 16, so x equal to 16 by 2, which is 8 kilometer per hour. Now x was the speed of the boat, so the boat was, speed is 8 kilometer per hour. Now when we want to find the speed of the water, we just substitute the value of x, which is x we know is 8, in say in equation x minus y equal to 5. So x minus y equal to 5. So y will be 3 kilometer per hour. And y is the speed of the water. So water will be 3 kilometer per hour. A man walks a certain distance with a certain speed. If he walks half kilometer an hour faster, he takes 1 hour less. But if he walks 1 kilometer an hour slower, he takes 3 more hours. Find the distance covered by the man and his original rate of walking. So in this sum we see that there is a man walking with a certain speed. So let a certain speed say x kilometer per hour. And it takes a certain time, say y, hours. And distance is speed into time. So the distance here will be x into y. In the first case, if he walks half kilometer faster, that means now it is x plus 1 by 2, half kilometer faster, he takes 1 hour less, y minus 1, this is time. Now his distance will be speed into time, which we know is xy, because it is the distance is the same. So we open the bracket here. So basically we have done distance equal to speed into time. We know the distance is xy. This is the speed and here is the time. So that is x minus 1 by 2 into time y minus 1. Now we solve this equation. Xy, we open the bracket. So we have xy minus x plus 1 by 2y minus 1 by 2. Xy cancels out. We bring all the x terms on this side. So plus x minus 1 by 2 equal to minus half. We'll take the LCM, and after we take the LCM we get the equation. Here we'll get 2x minus y over 2 equal to minus 1 by 2. You cancel out. So you get 2x minus y equal to minus 1. We'll write this as equation 1. Now we get on to case 2. So we know we had speed taken as x, our time we taken as y, and the distance was speed into time, so speed x time y. In the second case, if he walks 1 kilometer an hour slower, so x minus 1, he takes 3 more hours, so y plus 3. So the distance now will be speed into time. So we know distance equal to speed into time. The distance traveled by the body here is xy. So this is xy, speed is x minus y, and time is y plus 3. So we have xy equal to xy, open the bracket, plus 3x minus y minus 3. So we cancel it and we have 3 equal to 3x minus y. We will put this as equation 2. So this was one equation, and the next equation was 3x minus y equal to 3. If we want to solve this equation, we change the sign. So plus becomes minus, minus becomes plus, and here is minus. So this cancels out. So we have minus x equal to minus 4. So x equal to 4. And if you recollect, the x was the speed. So the original speed is 4 kilometer per hour. This is the original speed. Now to find the distance, we have to find the time. So we put x equal to 4 in any one of the equations. So 2x minus y equal to minus 1. So 2 into 4, x is, we see, is taken as 4, minus y minus 1. So minus y, you get minus 9. So y equal to 9. Now distance was speed into time. If you recollect, it was x into y, which is x we know is 4 and y is 9. So the distance equal to 36 kilometers.